Hello students, welcome to part 3 of this 4-part lesson of section 1.2 of AP Calculus. Today we're going to be looking at some piecewise defined functions, and we're going to go over several examples from some of the algebraic analysis that we've been using with limits from our previous lessons. So let's get started. So what I want to start with is by writing the equations of each of these pieces. So what I notice here is I've got a piece happening right here, I've got a piece happening right here, and another piece happening there. So I've got 3 pieces to write in, and in the first one, this is just a linear equation. I notice that the slope is -1, so negative x, and that the y-intercept is -5, so -5. And if I want to constrain this piece, all these values are going to be less than -3 right there. So I'll say, okay, x is less than -3. All right, so now I want to do this middle piece, and I have this parabola right here. And the easiest way to write a parabola is by using the vertex form of that. So I notice that the vertex is 1 to the left and 6 down. So 1 to the left, remember if it's inside the parentheses, it's going to do the opposite. So that makes it move -1 space. And it's a parabola, so it's going to be squared. And then it goes 6 down, so -6. And I want to constrain the pieces. So on the left side, I'm coming from -3. So basically, if I read this backwards, x is greater than -3. But then it goes over here to the right side to 2. And since that one's filled in on the right, I'm going to say less than or equal to 2. So x is greater than -3, and it is less than or equal to 2. Now I'm ready to do the final part of this piecewise function. And on the right side, okay, we're starting from 2, but okay, what's the slope first? It goes -1/2, so -1/2 x. And I want to see, okay, what is the y-intercept? It looks like it'll be -1, so -1. And what's the constraint on that? The constraint on that is going to be x is greater than the value 2. Not equal to, because it's not filled in at that piece right there. All right. So we're going to use that information from the piecewise defined function to understand some of these limits. So if I'm using the limit of f of x as x approaches 2 from the right, okay, all I need to do is 2 from the right. All right, values that are to the right of 2 are greater than 2. So I'm going to use the values that are greater than 2, and I'm going to use that function. And I'm just going to substitute in a 2 now. So -1/2 times 2 minus 1 equals, 2's divided out, so -1 minus 1 is -2. Now, the limit of f of x as x approaches 2. Remember, if it's a specific value, then we need to do it from both sides. I just did the right side, so I'm not going to do it again. So I'm going to do the left side now. The limit of f of x as x approaches 2 from the left. So values 2 from the left, I'm going to be using our second equation. So values that are left of 2 are less than 2. And so that's how I know, okay, x is less than 2 right there. So I'm going to substitute 2 into this equation. 2 plus 1 squared minus 6. Okay. And I'm going to evaluate this, and I'm going to get, okay, 3 squared is 9. 9 minus 6 gets me 3. So that's the left side. But the right side was -2. And since those aren't matching up, I have that jump discontinuity that's happening there. The limit does not exist. So we'll write does not exist because you always need to provide a reason, because the limit of f of x as x approaches 2 from the left does not equal the limit of f of x as x approaches 2 from the right. All right, moving on to C. The limit of f of x as x approaches -3 from the left side. So values left of -3 are going to be less than -3. So I'll use our first equation, -x minus 5. Okay, so -3 minus 5. And from here, I'm going to get +3 minus 5, so -2. Now in our second one, in part D, it's the limit of f of x as x approaches -3 from the right. So I'm going to use our second equation. -3 plus 1 squared minus 6. Okay, so -3 plus 1 is 2. 2 squared is 4. 4 minus 6 is -2. And in part E, the limit of f of x as x approaches -7. Well, which one am I going to use? I'm going to use that first equation because -7 is less than -3. So negative 7 minus 5. We evaluate that to 7 minus 5, so I'm going to get +2 in this case. And now I've got one more f. The limit of f of x as x approaches -1. So -1 is in the middle of -3 and 2. So I'll use our second equation right there. -1 plus 1 squared minus 6. -1 plus 1 is 0. 0 squared is 0. 0 minus 6 gets me -6. So you can also see most of these values in the graph, but now we're using the equations from the piecewise function. And you need to make the decision about which of those piecewise functions are you going to use depending on the constraint that's given. So now we're going to go through this example together. All right, so -2 from the left, so those are values that are going to be less than -2. So -2 from the left, I'll substitute in -2. So 2 times -2 squared plus 3 times -2. And -2 squared is 4. 2 times 4 is 8. 8 minus 6 gets me 2. Now let's check it from the right side. So I'm going to use our second equation. -1/2 times -2 plus 1. So -2 and -1/2, that makes 1. 1 plus 1 is going to get me 2. So what's the limit of g of x as x approaches -2? Well, we just did the left side and the right side. So all we need to do is say, okay, those are equal. Since they're equal, the limit exists at that point, and it's going to be the same value too. All right, now you might have noticed that this video is going to be longer than a lot of the other videos that we're doing. The reason for that is because this has a lot of examples to go through. What I would encourage you to do is try some of these examples out on your own. But if you need to see how it actually gets worked out, come and use the navigation that's at the bottom and just watch that one problem as you need, and I'll go through it with you. Otherwise, if you think you're good on all of them and you've checked the notes, then you can just fast forward through this part. All right, so here in our first problem, I'm going to substitute in e. So I'm going to get the natural log of e over 2 times e, so 2e. And the natural log of e is 1, so I get 1 over 2e. So now I've got 5 from the left side, so all I have to do is substitute that in. So 2 over 5, and then 5 squared plus 2 times 5. 5 squared is 25. 25 divided by 5 times 2 is 10. 10 plus 10 is going to get me 20. Now in this trig one, we're going to substitute in pi. So sine squared of pi plus 2 cosine of pi. So let's look at this. Sine of pi is 0. So 0 squared, that's going to be 0. So that first part is all going to be 0 right there. So cosine of pi is -1. So I have 2 times -1, and that's going to get me -2. Here in this trig, we're going to be looking at tangent of alpha over alpha squared. Let's substitute in 5 pi over 3. So tangent of 5 pi over 3 over 5 pi over 3 quantity squared. All right, so tangent of 5 pi over 3, that's in the fourth quadrant, and that's going to get us square root of 3 over 1, so square root of 3 in the numerator. And it's going to be negative because the sine values, or the y value of that function, is going to be negative. It's in quadrant 4. And then let's square the denominator, so 25 pi squared over 9. And let's simplify this, so all we're going to do is multiply by our reciprocal, just flip and multiply. So negative square root of 3 times 9 over 25 pi squared. And just rewrite this, -9 square root of 3 over 25 pi squared. Okay, in part E, I have the limit of x squared minus x minus 6 on 2x plus 4 as x approaches negative 2. Let's actually rewrite this. So the limit as x approaches negative 2, because I can see that things are going to factor. So in my numerator, I've got x minus 3 and x plus 2. And in my denominator, I have 2 times x plus 2. So those are going to divide out. And I have the limit as x approaches negative 2 of x minus 3 over 2. So let's just substitute in negative 2. So negative 2 minus 3 over 2. And I have negative 5 halves. Okay, in part F, we have x plus 5 over x squared plus 9. Well, that can get factored, so let's write that out. The limit as x approaches 3 of x plus 5, and then in my denominator, I have x plus 3 and x minus 3. All right, so then nothing factored out, but if I substitute a 3 in, right here in this part, I get 3 minus 3, so that's 0, and I end up with 0 in my denominator. So I end up with basically going 8 over 0. And since I have that happening, there's a vertical asymptote, there's something weird happening there. So the limit at 3 does not exist. Now in this problem, I actually have a difference of cubes in part G. And so I see 8 and 27, both of those are cubed. So 8 is 2 cubed and 27 is 3 cubed. So I actually have 2x quantity cubed and I have 3 cubed over there. So that can actually be factored, difference of cubes. So you can have a difference or a sum of cubes. And what happens here is we'll have the limit as x approaches 3 halves of 2x minus 3 times, let's see, 4x squared plus 6x plus 9 over 2x minus 3. Well, what happens with that is these divide out, the 2x minus 3's are gone, and now I can substitute in 3 halves. So let's do that. So 4 times 3 halves squared plus 6 times 3 halves plus 9. All right, so 3 halves squared, that's going to give me 9 over 4. And then the 4's are going to divide out, so I have 9 plus 6 times 3 halves, so that's going to be 3 times 3 is 9, plus another 9, so 9 times 9, or 9 plus 9 plus 9 is going to get me 27. Here in part H, I do have something that we could rationalize. So I'm going to multiply it by the conjugate, the square root of 2x plus 5 plus 1 over the square root of 2x plus 5 plus 1. So I end up with the limit as x approaches negative 2 of 2x plus 5 minus 1 over x plus 2, and let's see, times the square root of 2x plus 5 plus 1. All right, so 5 minus 1 in the numerator, that's going to get me 4. And I could factor out a 2 from 2x and 4. So let's write that out. So the limit as x approaches negative 2, 2 times x plus 2 in the numerator. In my denominator, I still have the x plus 2. And I still have the square root of 2x plus 5 plus 1. Well, those x plus 2's divide out. So now let's bring this over here. And let's substitute in the negative 2. So I have 2 in the numerator. And then in my denominator, I have the square root of 2 times negative 2 plus 5. And then plus 1. So 2 times negative 2 is negative 4. Plus 5, that gets me 1. The square root of 1 is 1. So in my denominator, I have 1 plus 1, which is 2. So overall, I have 2 over 2. which is 1. So it can be really, really helpful to rationalize some of your functions. In part A, we're going to do something very, very similar. Rationalize this. So we're going to multiply this by 1 plus the square root of 2x squared minus 1 over 1 plus the square root of 2x squared minus 1. Okay, let's see what happens. So the limit as x approaches 1. So I have 1 minus 2x squared minus 1 over x minus 1 times 1 plus the square root of 2x squared minus 1. All right, so we need to distribute this. So I have 1 plus 1 in the numerator, so that's going to get me 2. And I could factor that out. Wait, I got to write it out. That's a little bit too much to keep in my brain. Limit as x approaches 1. All right, so I'm going to have 1 minus 2x squared. No, not 1. 1 plus 1. Okay. I'm going to have 1 plus 1 right there, so that's going to be 2 minus 2x squared. That's fantastic. Okay. Over x minus 1, square root 1. Sorry, not square root. I'm getting too excited now. All right, so parentheses 1 plus the square root, 2x squared minus 1. Sorry if that looks a little bit sloppy. I'll clean it up as I go. All right, so in my numerator, I'm going to factor out a negative 2. So I'm going to have the limit as x approaches 1, factor out a negative 2, and I'm going to get x squared minus 1 now. And then in my denominator, I'm going to have still the x minus 1. Nothing has changed in the denominator. 1 plus the square root 2x squared minus 1. But x squared minus 1, that can be rewritten as x plus 1, x minus 1 with the factors. So the limit as x approaches 1, negative 2 times x plus 1, x minus 1. All over x minus 1, which is going to divide out, times 1 plus the square root of 2x squared minus 1. So those divide out, and now let's see what happens when I actually make the substitution. So I get negative 2 and 1 plus 1. Then in my denominator, I get 1 plus the square root 2 times 1 squared minus 1. Let's simplify that. So I get negative 4 over 1 plus, so 2 minus 1, that's 1, so 1 plus 1. So I get negative 4 over 2, which is negative 2. I know it's a long problem, but you gotta be very comfortable and very careful with a lot of these algebraic skills. Okay, so we want to combine these fractions that we have in the numerator. So let's go ahead and do that. So the limit as x approaches 0. So in the numerator, 1 times x is going to get me x. And then 1 times x plus 2 was x plus 2. And now I have x plus 2 times x, all over x in the denominator. So I can simplify this, and then I can simplify the entire thing just by multiplying by the reciprocal. So the limit as x approaches 0 of 2x plus 2 over x plus 2 times x times 1 over x. Okay, so let's see what happens with this. I could factor my numerator 2 out from both of those terms. So the limit as x approaches 0 of 2 times x plus 1 over x squared times x plus 2. All right, that's not what I was hoping would happen. So let's look at this. If I substitute 0 in, I'm getting 0 in my denominator. I'm getting 2 in my numerator. So I get 2 over 0, which means that the limit does not exist. So because if I substitute in now, even after all of that work, I get 2 over 0. So the limit does not exist. And that's because I was hoping that the factors would divide out, but in this case, the factors didn't divide out, and that ended up like disappointing me. But that's not always going to happen in every single case. So sometimes you will get problems that just you do all this work, and the limit never existed in the first place. In order to see what's actually happening here, we would need to do more analysis at the point x equal to 0 to see exactly what's happening with the vertical asymptote. Is it going, are they differentiating like positive, negative? Are they both going positive, positive? To see what's happening around the asymptote. But overall, the limit does not exist. So now we want to do this from the right side. Let's start by factoring. So the limit as x approaches 2 from the right side. And so I'm going to get 6 over here. I'm going to just write this out to the side. And I'm looking for 2 numbers to multiply to be 7. And that's going to be 6 and 1. And I divide both of those by 3. All right, so I get x plus 2 and 3x plus 1 in the numerator. And then over here in the denominator, I shall have x plus 2 and x minus 2, which is great because the x plus 2's divide out. Now, since I'm looking at it from the right side, notice here if I substitute 2 in, I get 2 minus 2 in my denominator. And I'm going to end up with 0 in my denominator again. So since I'm looking at it from a specific direction, this is different from our last problem. Since I'm looking at it from a specific direction, what I need to do is substitute in a number that is just to the right of 2. Let's use 2.1. So 3 times 2.1 plus 1 over 2.1 minus 2. And let's just look at, all right, what are the signs doing? So in my numerator, I get a positive plus a positive number. So I get a positive in my numerator. And in my denominator, I get 2.1 minus 2. I still end up with a positive number. So positive there. So that means the infinity that it's going to is actually positive infinity. So this comes out to be positive infinity in this case. We've got 2 more like this where we need to check those. So let's go ahead and do that. So, all right, so 2x plus 5 over x minus 3, and we're checking 3 from the right side. So we'll just put in value just right above 3 because nothing's going to factor here. So 2 times 3.1 plus 5 over 3.1 minus 3. So over here I end up with a positive over positive. All right, and that means that the limit is actually going to be equal to infinity from the right side. Now in this second problem in part M, it's the same function, but we want to look at it from the left side. So a value just to the left of 3, we'll use 2.9. So 2 times 2.9 plus 5 over 2.9 minus 3. All right, so I get a positive in my numerator, and in my denominator, I get a negative. So what happens with this? Well, this ends up to equal negative infinity. So at 3, I have a vertical asymptote. From the right side, I'm going up to positive infinity, and from the left side, I'm going down to negative infinity. And for our last problem, we're going to look at, okay, now I know there's a lot happening here, but we just substitute in x plus h or minus f of x, and that's what we need to find. So here's our function f of x, and I want to substitute in x plus h into each of these. Okay, so the limit as h approaches 0 of 2x plus h squared minus 3 times x plus h plus 4 over, oh, I missed a little bit. So minus f of x, which is just all of that again. So minus 2x squared minus 3x plus 4 all over h. All right, so let's simplify this out a little bit. Let's see what happens. Okay, so the limit as h approaches 0. All right. So 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 4 minus 2x squared plus 3x minus 4 all over h. All right, let's keep it going. Now this one's looking big right now, but it's gonna become small in just a moment. So let's look at some things that are happening. Still have the limit as h approaches 0. All right, so I have 2x squared, but that's going to cancel out with this 2x squared. So those are gonna be gone. And then I have 4xh, but I don't have any other 4xh's anywhere else. So I'm gonna leave that here, so 4xh. And then I have h squared, or sorry, 2h squared. Do I have anything else to combine that with? No, I don't. So plus 2h squared. And then, all right, so minus 3x, that cancels out with this positive 3x. And then minus 3h here, nothing else to combine there, so just minus 3h. And then it says plus 4 and then minus 4. So those cancel out. So it became very small very quick, and it's still over h. All right, so what I notice in my numerator is that I can factor out an h from each of those. And so now I just have the limit as h approaches 0 of 4x plus 2h minus 3. So the h's all divide out. I factor that out and it divides out with the h in the denominator. So let's actually substitute in 0 now. So we substitute in 0, so I have 4x plus 2 times 0 minus 3, which simplifies to be 4x minus 3. So all of that work just to get it down to a smaller function, in this case, 4x minus 3. All right, so I know that this was a long one. Hopefully you're not struggling through all of those problems. Maybe you struggle on a couple of those. But if you do need help, please reach out to me specifically so I can help you. And we do have one more part remaining in this series for this section. So do watch out for that next video coming out. I'm Mr. Hernandez, and I'm always here to help.